Okay, the goal for this lesson is to be able to find the inverse of a given function. And we are going to find inverses given a table or given the equation. We're going to find it from both ways. And the first thing we're going to do is find the inverse looking at a table. And then once we find the inverse, we're going to determine if the inverse, this new thing that we just found, is a function. Well, how do we know if it's a function? Well, if it's a function, for every x, oh wow, I can't spell today. Third time's the charm. For every x, there is exactly one y. Okay? So that's how we know if something's a function. So on problems 1 and 2, the first goal is to write the inverse. The second goal, once we know it's an inverse, is determine if it's a function. Well, how do we write the inverse? Well, when it's a table, all we have to do is flip the x and y. Okay, and this notation right here is the notation for the inverse. So this is indicating that this box here is the inverse function. Oops. Okay, so to get that, all you have to do is flip the x and the y. That's it. Very simple. Now, once you flip the x and the y, we have the inverse. Now that we have the inverse, we're trying to decide if the inverse is a function. So the easiest way to check is to look at the x's. Since none of the x's repeat, there's no way we can get more than one answer when we plug in x. So this is a function. And I know that seems a little confusing, but let's compare that to example 2, and I think it'll make more sense once you see example 2. So step 1 is to flip the x and the y. So this is going to be 6 and -3, 4 and -2, so forth and so on. Okay, so this right here is the inverse. We found it. Now we need to see if that particular inverse happens to be a function. Well, how do we know that? So we're going to look at the x's. Well, it just so happens the x occurs more than once. Okay, and when the x occurs the first time, we get an answer of -1, and here we get an answer of +1. For it to be a function, every time you plug in an x, you can only get one y. But on this, when I plug in 2, I get more than one answer, so this one is not a function. So when it's a table, to find the function, all we have to do is flip the x and the y. The same idea is pretty much true when we have equations, we just have to do a little bit more work. So step 1 is to flip the x and the y. And the second thing is to solve for y. Now, when I solve for y, that doesn't mean get an answer like y equals -12. You're going to write it, you're just getting that equation in a different forms, so it says y equals. So what do I mean by that? Well, let's look at example 1. We know that f of x represents y. So the first thing we're going to do is follow step 1 is to flip the x and the y. So we're going to write x equals 2y minus 5. To solve this equation for y, what we're going to do is we're going to add 5 to both sides, and that's going to give us x plus 5 equals 2y. Well, y is still not by itself yet, so I'm going to divide by 2, so that gives me x plus 5 over 2 equals y. Now, this right here is the original, and this right here is the inverse. Okay? Now, when I write my final answer, because this is an inverse, instead of writing y, remember I said that y to the -1? That's the notation. So this is y to the -1. But we're in Algebra 2 now, so we're not going to just write y to the -1. We're going to write it as a function notation. And in functions with an inverse, we're going to say f of -1 of x equals x plus 5 over 2, and that's what your final answer is going to be. All right, let's try this again on number 2. Now, you don't have to write out this step. I was just kind of leading you to how we get that. And when you take a quiz before spring break, that's how you're going to write your final answer. Okay, number 2, step 1, switch the x and the y. So this is going to be x equals -2/3 x minus 4. Whoops, I didn't mean to write x again twice. Should have been a y. Flip the x and the y. Next step, I'm going to add 4 to both sides. So I get x plus 4 equals -2/3 y. I cannot divide by a fraction, so instead I'm going to multiply by the reciprocal. I do not change the sign, I just multiply the reciprocal, and the reciprocal is -3/2. Now on the right, this is nice because it cancels. On the left, we're going to have to distribute. So that gives me negative 3/2 x, and then negative 3/2 times 4, well, we can use our shortcut. 4 divided by 2 is 2, times the negative 3 gives me negative 6 equals, and we don't write the inverse of y, we write the inverse of function x, which is written like that. Okay, let's try a few more. Number 3. First things first, we got to flip the x and the y. So I have x equals y squared minus 4. So to solve, I'm going to add 4 to both sides, and that gives me x plus 4 equals y squared. From here, I need to take the square root of both sides. So I end up with the square root of x plus 4 equals, and it's the inverse of y, and the way we write that is the inverse of function x, which is this. Okay, number 4, switch the x and the y, so I have x equals the square root of 2x minus 1. Oh, I did it again. Not paying attention. Here's, oh dear. Okay, so x equals the square root of 2y minus 1. So now we got to square both sides, so I get x equals, or excuse me, x squared equals, when I square the radical it cancels and I get 2y minus 1. So now I need to add 1 to both sides. So I have x squared plus 1 equals 2y, divide by 2, use our function notation, so the inverse of function f is x squared plus 1 over 2. Okay, here we go again. Number 5, switch the x and the y, so we have x equals 2y squared minus 5. First step, add 5 to both sides. So I get x plus 5 equals 2y squared. I may recognize you need to take the square root, but we can't do that until the y is by itself. So I'm going to divide by 2 first. So I have x plus 5 over 2 equals y squared. Now we're going to take the square, whoops, why is it writing? Now we're going to take the square root. So on the left, the entire fraction is under the radical, and that equals, and then we're going to use our inverse notation. Okay, one last time, number 6. So the first thing we need to do is to change the x and the y. So I have x equals the square root of x minus 3 over 7. Now to undo that radical, I'm going to square both sides, giving me x, I said 7 and then wrote a 2. Okay. And when I do that, I get x minus, oh, wow. Let's see if I can write this again correctly. I keep making the same mistake over and over again. X equals the square root of y minus 3 over 7. I apologize. Okay, so now I'm going to square both sides. So I get x squared equals y minus 3 over 7. You can't add 3 to both sides until you deal with the 7. So to deal with that, I'm going to multiply both sides by 7. So I get 7x squared equals y minus 3. Add 3 to both sides. So 7x squared plus 3 equals the inverse of our function x. And that's our answer.